So, we've got the real heavy technical content today with transport, but we've got a couple things this morning that should be eye-opening. Hopefully everyone's eyes are open. Thank you to Vesta Plus for the wake-up session out there with the coconut waters and Gatorades and Red Bulls. I would say this is probably the most in-depth AI conversation to start the morning. Not in a bad way, but in a really good way, really thinking about the depth of how AI models focus on what we do and how standards can help them. We're going to talk a little bit about the benefits we create for our community because it's more than technology. Sometimes when we get into our second session, it's more about our community. And then, of course, the technical transport sessions. But to open us up, we have Michael Martin with Sidekick to give us a much more deep set of thoughts about AI and how it works in our business. Michael.
Thank you. Good morning. Can everyone hear me? Great. Thank you, Sam, for scheduling this 30-minute talk about AI and math directly after the hangover station. We talked about hallucination after last night's party. I want to make clear that there's two types of hallucinations that we might be having right now, one as a result of the band, and the other as a result of AI models. So the talk today is about hallucinations or insights. How can we use data standards to strengthen the output of an AI system? So just a quick intro, I'm Michael. I've been working in and around real estate data for 5 years now, most recently as the co-founder and co-CEO of Sidekick. Sidekick is a generative AI assistant that is built to help real estate agents and brokerages. So all the core functionality of a large language model, able to perform multiple sequential tasks in a sort of a goal-oriented manner, and built on top of MLS data and other real estate workflows. And so we've been fortunate to partner with a number of groups in this room, and we're awarded by Inman this year both most innovative use of AI and top real estate startup within AI. But today is not about Sidekick. Today is around AI. Isn't AI incredible? I mean, look at these images. The top left is Sora, the video generative technology by OpenAI. We have Stable Diffusion. We have all these really incredible, Elon's robots, like all these really, really incredible uses of AI that frankly stretch the imagination. I think when we think about AI, it feels like it's something that's really far away. The truth is the kind of curve of innovation and the curve of adoption is much faster, I think, than we realize. And despite all of this, despite the tens of billions of dollars that are being invested in developing these language models and building, 10-acre large data centers and building micronuclear reactors to cool them, Tim Cook 2 weeks ago said that it can't do basic math, right? So there seems to be a bit of a disconnect between how can you have these transformative next generation technologies that are truly able to create maps of the world when they think about how to be predictive with language, with reasoning, and at the same time they can struggle to do some pretty basic arithmetic. So what I want to cover today are really two questions. The first is, why do these incredibly powerful language models struggle at times to do really basic math? And then secondly, and more importantly for us, is what does this mean for how our industry can incorporate generative AI into a number of different workflows, knowing that it is probably something of an inevitability at this point. So let's get into it. So to sort of start off, I think the first important point is that language models see things very differently than we do, right? We look at a piece of paper, a number, a sentence, and we have sort of one way of interpreting it as humans. That is not how the language models are internalizing the data. They abstract the information. When someone types a prompt into ChatGPT or into any other AI application, the language model is abstracting that information out and interpreting it in a way that its system can understand. And it does that in a couple of different ways, which I'll get into. The first is tokenization. So we hear a lot about, if you've ever looked at the pricing for, if you integrate an API from OpenAI or from Google or from Meta, they'll charge things in terms of price per token, right? So for the latest models like GPT-4o, it's like $5 per million input tokens and $15 per million output tokens, right? So it's usage-based pricing. So tokenization is a really important point. I also want to note that in the last 2 years, since GPT 3.5 first came out, the cost per token has gone down 230x, right? So we think about what is the barrier to entry, why is the adoption curve growing so quickly, why are so many AI native applications being developed? In part, it's because the economics underlying these systems are becoming much, much more accessible for groups that aren't large enterprises. It could be a small team, right, building off of these models. So tokenization, the first important point. The second is something called positional encoding, which is within a prompt, right, every token has a position in relation to something else, right? And so for the model to make sense of what the prompt is doing or asking for, it needs to create these interrelationships between the tokens within the prompt. And that can cause an additional layer of confusion. Now, these sort of abstractions, the tokenization, the positional encoding, these can be managed, right? They can be managed in the domain layer, on top of the language model, right? So as an application developer, there's a degree of control. And also, if the data models that are going into these applications are normalized, you can deliver accuracy. But I think fundamentally, it's important to remember that AI is inherently probabilistic, right? What AI is good at is sort of saying, okay, based on this prompt, this is the likely intent, and this is the likely next word that needs to be generated to make sense. And math is inherently the opposite, right? It is deterministic. There is a right and a wrong answer when you're doing a math problem. And even when we think about our kind of typical interaction with data through an application, it's a lot of deterministic interfaces, right? You're presented with a home screen or some sort of page that has drop-downs. Those drop-downs have filters. You can filter by something like number of bedrooms, square footage. Those are all deterministic filters, right, that are indexed against a schema in the background. When you're engaging with the language model to access that data instead, you're combining a probabilistic element with a deterministic goal, right? So how do you minimize that gap as much as possible so that you have confidence that the answer that the model is giving you isn't something that it's making up? So let's get into tokenization. This is a number. I'm not going to say what this number is. I'm sure we all are looking at this number, and we know what this number is, right? If I asked everyone in this room, we'd probably all give the same answer. But if you're an AI and you're abstracting this information to a token, you have a lot of different interpretations of what this could be, right? This could be 483,647. This could be two numbers, 483 and 647. Or maybe the person forgot to put a space after the 48, and it's actually two different numbers, 48 and 3647, right? So if left to its own devices, you're asking the language model to make an assumption around how to interpret this number into a token, set of tokens, that it can then perform processes on top of, right? And most of the time, a lot of the time, it might know what you mean based on the context of what's before and after it, but not every time, right? So this is like a pretty clear way that you're introducing a margin of error when inputting numerical information into a language model. So let's go to the second piece, which is positional encoding. So you ask a pretty basic addition problem, right? Adding up three numbers. Well, the AI is going to put it into some sort of array, right? And that array is going to treat each of those numbers and the commas and the plus sign and the spaces as its own sort of position, right, within an array of tokens. And each of those positions is going to have some sort of longitude and latitude, right, based off of where those tokens show up in the prompt. So here, you have these different rows and columns. I've just labeled them like 0 through 29, right? So you could map each of these individual pieces of this math problem into a specific box. And you remember, like, how do we add up numbers, right? You start on the far right, and you add up the first column of numbers, and you carry the one, and then you add the next column. Well, when that first column of numbers is not lined up, right, you're now asking the language model to know that in this addition problem, the 7, the 4, and the 4 are all the first number that need to be added up, when in fact they're not aligned that way, right? So now you're introducing a second layer of positional assumption that the model has to make to sort of say, okay, not only do I know what this number represents, but I also know how it needs to be combined with other numbers that are also similarly structured, but positionally different based off of how addition works. Does that all make sense? Okay, so what does that mean? Well, we know that agents, in particular, want a path of least resistance when it comes to how they can access and analyze data, right? So there was an Inman survey that came out, I don't know, 6 months ago, which is pretty remarkable, that like 85% of this entire industry is using either ChatGPT or some other language model in their daily workflow, right? And that shouldn't be a huge surprise, right? It's so approachable, right? The conversational aspect of like ask a question, get an answer is really easy to learn. It's really approachable. It's like texting someone. It's like emailing a person asking for something, right? But we know that a lot of the usage so far has been like marketing focused. It's been a lot of like, help me draft an email to someone, or like rewrite this listing description to sound more geared towards like a young professional, which is great, right? Because a lot of things I just talked about don't really come into play. Now, what happens if you want to take the power of that language model and get insights out of how's my market doing? Or tell me how to think about the carrying costs of this property versus the other property in different like refinance scenarios. Like those are things that agents need to do, that they want to be able to do, but they can't yet do. So if we can figure out how to combine the power of these language models with integrations into MLS data and real estate workflows, there's enormous value and time savings and efficiency and speed that can be unlocked, but there has to be a good architecture surrounding it. And it's also really important, there's a lot of companies emerging in the AI space that are building these really cool features that can work for real estate, they can work for financial services, they can work for restaurants, they can work for all these other industries. The capabilities of these general language models, whether it's from OpenAI or Claude from Anthropic or Llama from Meta, like the horizontal capabilities are going to continue to grow. But what those companies will never do is go deep into a vertical like real estate, right? I would bet a lot that ChatGPT is never going to have training data based off of the MLS, or have like the ability to generate a CMA, or any of those very specific mission critical tasks that agents have to do all the time. So it really is incumbent upon everybody in this room to get this right. Because if we do, there's an incredible outcome that could happen in a positive way. So what's the approach? Very simply, don't ask the AI to do math. Just don't try, don't do it. MLS data should never be plugged into like a language model directly, right? If you're just like, hey, I have ChatGPT, I'm gonna upload a CSV of like 1 million listings from the MLS and then ask it a bunch of questions, like you're not gonna like solve any of the issues that we talked about with tokenization problems, with positional encoding. But if you think about the language model as a coordinator, as an interpreter between what's the user asking to do, how's that information passed through the API, what are the core services at the applications performing, how is the database in the background structured, the model can be very powerful in helping translate and interpret and relay information back and forth, but the heavy lifting of the math is not being done by the model. It's being done by whatever the application is. So I'm going to show you an example architecture of how we've been building it at Sidekick. So in the bottom, you have a front end. Someone types a question, goes through an API. That API is connected to the core services of Sidekick, right? And then in the background, we have the data sources coming in, which could be MLS data feeds. It could be other data that we use to enrich that information, which go into a database that we manage, right? And in that database, we run an ETL process. We do the geolocation, all the mapping, all the processing. So a prompt comes in. Let's say that prompt, someone says, hey, tell me XYZ about this market over this time frame, whatever it might be. The core services say, okay, now this is a job for what we call the query engine. So it sends that prompt to the language model. In our case, we use a few different ones. The language model says, okay, I can interpret this sentence and generate SQL, right? So it's SQL gen. It's essentially generating code in the form of SQL that our query engine can then take, run against our database, get the data, perform the analysis, whatever the analysis is, and then send that result back to the model as a JSON file. And the JSON file in the model can then deliver it to the user in whatever format they're asking for, right? Do they want it as an email? Do they want it as an Instagram caption? Do they want it as a spreadsheet? Whatever it might be. So in this sort of architecture flow, you're not asking the model to query the database. You're simply asking the model to say, hey, here's a really dynamic and specific, nuanced query that someone has that relates to the data in the back end. And we don't have a deterministic set of dropdowns and filters or any of that, right? So you don't have that scaffolding to rely on. How can the model interpret and then generate code that then allows the back end to deliver the right result? So here's an example, and this is like really hard to see, but you don't need to necessarily focus on the words. So I asked, and this is our API test environment. This is not the actual interface of Sidekick. This is just like how we test the API. I asked, what is the median time on market over the past 5 months for condos in Russian Hill versus single-family homes in Pacific Heights, specifically for properties between 3 and 5 million? Right? You're noticing I'm using abbreviations, like I say BTW, I'm saying 3-5M, I'm SFH, right? All this sort of like jargon. Within probably a fifth of a second, the output on the right side is all SQL that the model generated, right? And so it's understanding the neighborhood is Russian Hill, the city is San Francisco, the subtype is condo, the price range is this, the periods are 5, the period type is month, and then it's joining a bunch of columns and databases and pulling from different information and just doing a bunch of like index lookups, like all of this custom SQL code is being generated by the model. And if you're using Sidekick on the front end as an agent, and you ask it the same question, within probably 5 seconds, you get the answer, median time in market in the last 5 months for condos is 61 days, SFH in Pacific Heights is 91 days, and this is for properties between 3 and 5 million. So you've now effectively, what have you done? You've taken the interpretation off the hands of the model, you're really just asking it to write code, which unlike math, it's actually really, really good at, right? Like, you think about like Copilot, which is like a GitHub product. Like, pretty much every developer right now is using some sort of Copilot companion when generating code, whether that's SQL or Python or really anything. And you're also providing a conversational front door. Like, if you're an MLS, you now have a conversational front end that you can offer your members to access your information. So like now it's easier than ever for agents to make good use of the assets that an MLS might have without the cognitive load of having to go into UI, hunt and peck for what you're looking for, know how to export CSVs, know how to combine them, know how to do Excel formulas around them. Like, this prompt involves a time on market, a fairly random date range of 5 months, property types, 2 different neighborhoods, and a price range, right? So you think about like, you're unlikely able to do this really quickly by like clicking filters. It'd probably be like multiple searches, multiple exports, and then a bunch of manual joining on your side. So this is the power of how an AI assistant can really give time back and also deliver accuracy. So really, when we think about a data-driven application, like a real estate data-driven application, AI is a really, really powerful tool to supplement that. But the quality of that result is going to be reliant, and this is why this is exciting to be here. The quality of that result is going to depend on the completeness of the data and the accuracy of the data, number one, right? It's like garbage in, garbage out. And we also hear a lot about like, well, can you use synthetic data, fake data, right, to kind of give it familiarity? And that risks something called like model collapse, where if you feed a model like too much fake data, it starts to iterate kind of in this downward spiral, and it just like loses all of its value. Number two, it's the structure and the elasticity of where the data is being housed, right? So one of the things that we had to do when building the query engine was also think about the database structure and how it could be sharded in any sort of way. Like, imagine a spreadsheet in Excel is like a 2-dimensional object with rows and columns. So like, imagine you have like a stack of 1 million spreadsheets, and you want to be able to like shard off a chunk of it like an iceberg across any different XYZ axis, right? So the backend needs to be able to do that so that the SQL query can effectively pull it. And then obviously the implementation, the orchestration, the language model has to make sense too. So those are kind of the three, if you're building an AI application, those are the big three things to think about if that application is data-oriented. And this is the really important point, is like basically from yesterday until who knows when, pretty much every application that is going to get built that pulls in data from an MLS and does something with it is going to be leveraging AI. Like, unlike the applications of the last 20 years, where they were, leveraging the cloud, right? It was like the interfaces got better, the storage mechanism became different because we had cloud architecture, but the fundamental nature of like pull data into a database and do work on it, that hasn't really changed. Now this is actually different, right? They're all going to be AI native applications. So what does that mean? It means, first of all, universal standards of the data are like mission critical for this to work well. Like for the good of the industry, all the data needs to be RESO compliant. Like there's no, I was like a non-negotiable. But also that there are some additional opportunities. Like if you are the owner of an MLS database and you know, okay, people who are building AI applications are gonna be using my information, how can I make it easier for them to like limit the amount of work that they need to do to clean all it up, right? So there are opportunities around just enrichment, around geolocalization, if you're doing market-related queries, and even to some extent the tokenization problem, right? There's ways to potentially tokenize the feed that you're delivering or enrich the data with some token elements so that there's less interpretation required on the model. And I guess as a last thought, I want to be very clear that nothing I showed just now is training the AI, right? Like Sidekick or applications like it. We're not training a language model on MLS data. Nothing to do with that, right? What we are doing is training an AI model on a schema that is structured to make sense for how people want to access MLS data. But all the data is living separate and apart, right? And that's really important. The last thing anybody should want to do is open source MLS data to a language model so that you basically get rid of any permissions or authentication requirements or access requirements for that information and build it into the broader corpus of knowledge of a language model. Like that's like a big mistake. So hopefully that was a good insight and glimpse into how we're approaching that problem. I'll be around if there's any other questions. I really appreciate everyone, and thanks so much.